Okay, so when we're talking about these action potentials, sometimes it gets confusing because we show cells like this. But for the most part, when we're typically talking about the action potentials, we're talking about the neurons running from our brain to our muscles, It's all about sending signals, okay? So if I want to flex my arm, I have to send a signal to my bicep saying, I need you guys to contract. So that signal has to be sent. And so what's interesting is, so have you seen a neuron, like a neuron cell body?
Yep.
Okay, let's see how well you can label stuff. Do you know what I'm drawing? This big part.
Isn't that like the soma?
Yep, soma.
And there's dendrites attached.
So if we didn't make our parts and we got rid of $25 per.
So soma, dendrites.
And axon, or it's made up of axons, right?
This is the axon.
Okay.
So this is, real quick, this area right here, it's called the axon hillock.
Oh, yeah.
Trying to think if it's a double L.
Yeah, let's read the rest of this problem.
Probably spelled that wrong, but
Facilities now being used to manufacture could be rented to another company.
and then do you know what's down here? It's gonna be that axon terminal.
Terminal, yeah, the end.
Yeah, so terminal meaning end, okay? Okay. So in general, graded potentials are gonna happen out here, and action potentials are gonna happen from here on, okay? That's a general idea, and I'll explain what the difference is. Okay, so in this area of the soma and the dendrites, because that's where they're going to be receiving the original signal, right?
Okay. Yeah.
Because the signal is going to start here, and it's going to travel down, okay? So the signals can come from a lot of different places. So there can be a positive signal right here, and an inhibiting signal right here, positive right here. And so what can happen is they can affect each other. So this one can start going like this, these two positives, when this negative comes along, it pushes it down a little bit. Okay? Does that make sense?
Yeah.
So there's some things that are gonna depolarize the cell, and there's gonna be some things that hyperpolarize the cell. Okay.
So does it ever reach like another axon, another soma, axon?
What do you mean?
Graded potentials. You said it doesn't go along the axon. Does it reach another dendrite?
These signals, so like that positive thing, it's going along this way towards the axon.
Does it go along the axon?
Yeah, it's eventually.
Okay.
So with graded potentials, they can dissipate as they can dissipate as they travel, because there's different leak channels and things like that kind of start to balance out the charges. So say we just got one positive thing right here. What'll happen is it goes up, but then as it's traveling, it goes back down. Okay? But if we have two positives right here, it can summate.
Okay, summate. Just to add more.
And then as it travels, it would still go down.
Okay.
Okay? And so you can have this entire way until the axon hillock. There can be things that come in and make it go higher and a stronger, because if it's a stronger signal, you're going to be getting more signals from lots of places, right? Being pinched versus getting stabbed. And so it can get these stronger signals, okay? But once it reaches the axon hillock, there's a point called threshold, okay?
And
Where
that's for graded and for actions for any potential.
So up here was graded potentials, okay? And right here is where it's gonna switch possibly from graded potential to an action potential,
Okay.
okay? So,
But if it doesn't reach threshold, it remains graded potential. Is it
yeah,
never becomes an action potential. Okay.
yeah. So, got this one positive charge, okay? It comes, and this charge isn't great enough it's not high enough to hit threshold. So what it's gonna do is it's just gonna go back down, no signal is sent, okay? So it wasn't a strong enough stimuli to get a signal. But let's say we got 3 different things that are traveling down the cell, okay? What happens is they'll summate, and once they hit threshold is the point at which all of the sodium gates in that area, so, because when I'm looking at this, for example, it's like a cross section. So it's just a small area on the axon. So, like in this very small area, all of the sodium gates that are there, it hits a specific charge where it's going to be enough negatives to force open all of the sodium gates, okay? So once you open all the sodium gates, you get an action potential, which is an all or nothing event, okay? Whereas graded potentials wasn't all or nothing. The signal was still traveling down even if it was just a little signal. It just could dissipate potentially. So in the graded potentials we could have that, and that's still a signal. But once you get to the axon hillock, if it doesn't hit threshold, it's not going to make an action potential occur. And action potentials, once you hit an action potential, it's going to be propagated down the rest of the axon and send a signal.
How does it hit threshold? Does it just hit it from sodium going in?
So yeah,
Basically.
yeah. So the cell has to be depolarized enough to hit threshold. So that's going to happen from sodium entering in the cell.
And then once that happens, like, then what's the difference between going to the threshold and like the action potential? Like, will the sodium force just open up more?
So at this point, looking at your cell, you have hundreds upon hundreds of little sodium channels all around that thing. It's jam-packed full of different proteins and stuff. So at a lower level, that's saying a couple of the sodium channels are opening. But there's a point at which enough sodium channels are open that it's going to kind of be like a domino effect. So that the charge is changed enough that it's going to open another sodium channel, and that depolarizes the cell more, which is going to open another one, which opens another one, which opens another one, causing the action potential. Okay. Whereas on the other ones, if 5 of them open, that's not going to cause the whole domino to spill over. Okay. So graded potentials aren't all or nothing, but action potentials are. Does that make sense?
Yeah.
So if we don't hit an action potential, or we don't hit threshold at this point, no action potential, no signal.
What would how would magnitude and amplitude play into this?
Can you open your book up?
Yeah.
If I was a teacher, I would be so much better at everything.